Good evening, friends. How are you all? After so many days, I, I have come again. Now I'm free. So try to continue my YouTube channel, video loading, uploading. Okay, now today we will discuss about the TRD estimate, traction distribution estimate. Here it is the OHE estimate. For OHE estimate, we can do it in two ways. Like one thing we can do, we can survey the site, and according to the survey of the site the requirement we can do. For example, suppose you have surveyed one site. There you see the length of the relay electrification, how much. If it is straight, horizontal, tangent track, or curvature. If it is curvature, how much curve. Then type of soil. Then the infringement in the site that you have to overcome. The wind pressure zone of that place. According to the wind pressure zone, your overhead OHE span you have to decide. Then type of OHE, if it is single phase 25 kV or 20-25 kV or 2 into 25 kV high rise OHE or 2 into 25 kV high rise OHE. And these four types is now normally running in India. One is single phase 25 kV. Its normal height is 5.6 meter. Then the 20-25 kV, it is also 5.6 the contact height, and above contact and catenary there is a feeder wire. Then high rise OHE 20-25 kV, it is more than above than 7 meter, and another is 25 kV high rise OHE. Why 25 kV high rise OHE? For yard electrification. Just like you say, I have done the design of the JNPT takeoff. The DFCCIL which is 20-25 kV high rise OHE. From there I have converted it into 25 kV high rise OHE. In this system, the design will be somewhat, some changes will be there, like 2 into 25 kV to 25 kV you have to provide auto transformer, circuit breaker, a PTFE neutral section from main line to the yard line, for siding line. Yard line, not yard line, siding line, or for big yard. For big yard, you don't need neutral section if it is in the same DCCL section. But for siding, they are like Jawaharlal Nehru Port Trust. This is a long railway line, and here it will run double stack wagon, double stack freight service. So the height of conductor is high, but it is 25 kV. It is 25 kV. What we have done, we have taken the phase and midpoint of the auto transformer to keep it in 25 kV. Then you need circuit breaker. Then you need PTFE neutral section to isolate from 20 to 25 kV to the 25 kV high rise OHE. So this is the site survey. This is the site survey where you have to decide. First should know what will be the electrification. Then you can plan accordingly. So one thing you can do with detailed site survey, then you can prepare the estimate. And another thing is after preparation of layout plan, you can easily estimate the quantities from the layout plan. And if this layout plan is not there, somewhere it has been told this TKM will be electrified. From there also you can do some what? You can guess, you can make an estimate, not accurately, but this is as per the abstract estimate. In detailed estimate, we have to go detailed number of quantities, but for roughly when we are giving in the proposal of the railway board, we are doing this. For example, suppose they have told it will be a 20 TKM OHE, 20 TKM OHE. For tangent track, for single line we need 14 masts average and 28 mast in double line. But if it is curvature, you can take it more, because in curvature the span will be reduced and number of mast will be more. So you have to take for 1 TKM 20 to 22 mast. Again the wind zone, according to the wind zone, if it is the high cyclonic area, then your span will be reduced to stop the swinging of contact catenary to go out of pantograph running. If your span is more, your contact will swing more during cyclone. So this is the idea. So in all these things you have to consider. Then you should know the type of mast, where you have to provide what type of mast. That is also a big thing. So suppose for normal mast we can use B150. That means single OHE, one conductor will run, one cantilever, then you can use B150. But according to the changes of cantilever and the load and the anchoring mast, the ATD mast, your mast size will change because due to more load, For anchor mast in 25 kV OHE you can use B175, B200 according to your load. Then somewhere, mainly in station area, the track separation is not too much, so you have to provide portal. So you have to decide for the portal or TTC, twin track cantilever. Twin track cantilever. If your implantation is not permitting between the two tracks, you provide it in from one track and catch the second track also. If it is in same elementary section, otherwise you have to provide individual TTC and for the line individual mast. Now, where you have to provide sectioning, that is also a main thing. This design aspect and this estimate your sectioning idea. Mainly we need sectioning in the station area, in the mid section, In DFCCL it has fully avoided, but in existing which when it is converted into 2025 kV, at that time we are converting the single pole isolator into double pole isolator. So all these things you have to keep in your mind. If it is a existing system, your system will be changed. You have to provide all the isolators in the double pole isolators, all the interrupters in the double pole interrupters for 2025 kV. And in the TSS also you have to plan neutral section. In SP neutral section must be there, and in TSS also your neutral section will be there. Then somewhat they are controlling this isolator also by SCADA, remote control, supervisory control and data acquisition system. The isolator is converted in motorized isolator so that remotely they can operate it. These isolators are motor operated isolators. So many changes in the system, but according to the requirement of the client, you have to do all these things. So isolator may be manual, single pole or double pole. For 25 kV it is single pole SPI. For 2020 it is double pole DPI. Interrupters are single pole in 25 kV, but for 2020 it is double pole. And in 25 kV we are not using auto transformer, but in 2025 kV switching post must be provided with auto transformer. And in Scott connection, in the TSS also you need auto transformer. So this changes is the main thing. Actually, what is the intelligence? First you know the average thing, then the changes. It is the main thing. What is the changes in that system? You have to think about that and you have to provide it. The changes. Then if it is on a bridge, the railway track is crossing a railway bridge, then you have to provide bridge mast. You have to provide bridge mast. Then uh, then your sectioning, I have told sectioning mainly is going to be done in station limit. So if it is new electrification, mainly DFCCL is maintaining the sectioning system in the station limit. Both sides there are two switching posts, and the mid section you don't have any sectioning. You don't have any sectioning. But in our existing system, we have provided section in the mid section somewhere. Somewhere we have provided mid section. So for designing and for the consideration of the estimate, you have to think about the sectioning also. You have to think about the sectioning also. Now we have given a chart of the estimate. First thing, you have to prepare a drawing. So the money for this preparation is to be included. Then for the mast, we have to do foundations. And soil is also varying. Somewhere it is hard, rocky soil. Somewhere it is bridges. Reinforced concrete for foundation and trench. Somewhere we have to provide some trench. What we have to provide trench? Trench is required for cable running in the switching post, in the TSS. This trench is required. Reinforced concrete for trench cover. Again this trench cover. Trench cover. You have to provide the trench and you have to provide the trench cover. This is the civil work. Supply of roller, fabricated and galvanized traction mast and auxiliary transformer. mast, feeder mast, bridge mast, etc. Auxiliary transformer, you know, it is for supplying 25 kV 230 volt single phase. Feeder mast, it is also its height is also more. Bridge mast, there is a change. I have told you the changes you have to think first. The average thing you can do it, but the changes is the main thing. So this is the first page of the estimate, and some portion I have given. So this is the system of estimate. Now in estimate, what we are doing, we are giving the unit. It is given in truck kilometer. What drawing design? What truck kilometer drawing design will prepare? That means length of the OHE lane. That is in truck kilometer. Then rate. One is supply rate, another is erection rate. Then normally our contract category is given from store. DG set from store. So many things is issued from the store purchase. So you have to include that thing also. Then add the two quantities in rupees, not in quantity. Total, it will be reflected. Then reference from where your rate reference. That means from where you have taken the rate. Rate mainly is taken from the last accepted rate. That means we are taking 3 LOS of different time and making it average the rate. And if it is not available in the LOA, then we can search the net which from authorized company, RDSI approved company, we can put this rate. For TRD, RDSI approved company is there, and for electrical general, we can take authorized company, which is indicated by, which is given by C, Chief Electrical Engineer, that you can include. So this is the rough idea of the estimate. Later I will tell more. Okay. Thank you, friends. Today up to this.